what I just did right there, that's a prototype. I'm actually not here to talk about pivot. I'm here to talk about carbon nanofibers. Give me 1 second. So it's really fun on the pivot, but as I said, I'm here for carbon nanofibers. I'm specifically here to talk about carbon nanofibers and their application to 3D printing. The Ume3d is a manufacturer of carbon nanofiber filament. The primary component is CO2. It's proprietary, the chemical process that we use to create it. And so basically it'll be printable in anything that you can do with a 3D printer. A variety of industries and uses have yet to be conceived for the material. However, we have identified the market needs. It's going to be any business that wants a relatively cheap, environmentally friendly base material. So this is the team. I'm Adam. I'm the science officer. That's Chuck Lee right there, and that's John Vital right there. Doug could not be here, but thank you guys for all your hard work. I literally would not be here if you guys hadn't helped me. The reality of being able to align carbon at the atomic level opens up really incredible applications that have not yet been tried. Unique compositions of carbon nanofibers can be blended into various polymers and used by many 3D printing methods, whether it's resin or direct film. In the end, the carbon nanofiber composition depends on the properties required for the application. That's why Ume3d will target other companies and individuals who are 3D printing right now. Ume3d's advantage in this new and rapidly developing industry is we are going to be producing tangible products that remove carbon dioxide from the atmosphere and put them into anything. So our marketing strategy is to sell directly to manufacturers, join organizations, and look for low volume, high cost products like medical instruments. Okay, so what we're going to start with is a 1.75 millimeter filament, and we're going to sell it for about $200. It costs about $30 a kilogram to make. So initially, we predict that we can sell 100 spools a month and then ramp up from there. These are very exciting times. The issue of climate change now has a profit motive rather than simply an expense to society. I will not diminish the scale required to fix the environmental issues and return carbon dioxide to pre-industrial levels. Ume3d will be part of the solution. The more of you that join us, the better. We're going to make really badass tangible objects. The uses are almost limitless. People will look back and say, how else would you make it? All right, so in the future, when we have this awesome material of carbon nanofibers, and it's carbon negative and the environmental side is getting sorted out, I'm going to work on the pivot, which you saw on the way in. And then after that, Ume3d will turn our attention to making starships for Starfleet. Thank you for your time. Long and prosper.
Okay, great. Thanks so much, Adam. And we will now open it up for questions. Anyone? Joe?
You touched upon this, but didn't really delve into it. I mean, it seems like the applications you said are almost limitless. Where are you starting? I mean, it seems like you need a little focus on these are the people we're going after, these are the manufacturers, these are the products, these are where we see the immediate.
Well, to start with, aerospace and medical. I know for a fact that Boeing is using carbon nanofibers in the Dreamliner. The fact is, the science has come so far along very recently. Carbon nanofibers were very expensive before, and it took a lot of really bad chemicals to make it. Now they don't. This is a process that came out of George Washington University in Washington, D.C. So, in terms of focus, it will be medical and aerospace.
Oh, those are two good places to be.
Yeah, I know.
Who's your competition? Who's your competition?
In terms of 3D filament and putting carbon nanofibers in it, I've been looking, I can't find them. I found a company out of the Czech Republic that's making sheets of carbon nanofiber, and I found a company in South Africa that's making sheets of the material, but they're not putting it into filament, and it's not something I can print with.
Is your process patentable?
We don't know. Maybe. The variety is this. The variety of the applications, I think it's going to depend on what you want to make. If you want to make it a table, you're going to use a much longer fiber. It's going to physically be longer, and you won't need as much in the blend. If you want something to be electrically conductive, you're going to need a higher concentration and better connection between the actual carbon nanofibers.
Other questions?
So I think a lot of the reason that these carbon nanofibers have been so expensive to produce is the quality control aspect to them. I mean, all of the applications that you're mentioning have really high quality control tolerances. How are you addressing those with your process? And the second part would be, if this is already in the open literature because it was published at GWU, how is it patentable?
Well, it's the application of a few other processes. We have, in terms of the quality control, we don't need to be that accurate. We have a method to put it into the filament. As long as they're connected, the carbon nanofibers physically, you can carry a current. The variety of lengths, given that it's 3D printing, that's actually an advantage because you're building it up layer by layer. Say, for instance, you want to make a battery. You're going to lay down one layer of the carbon nanofiber, then you're going to have some sort of a barrier so that it can produce the store the electricity. Then you're going to have another layer of carbon nanofiber. I'm sorry, did I answer your question?
Regarding the patentability of it, basically George Washington University has come up with one process. Okay, we are adapting that process, changing it, making it much more efficient. So that we're going to be basically patenting the manufacturing process. To make it. I mean, if somebody comes up with a different variety, that's fine. But we want to be the first ones out there.
And actually, as far as that process goes, we're not quite sure whether we should patent or not, because once you patent something, it's published and other countries can steal it. So we may actually go the route of just keeping it a trade secret as much as we possibly can, because there are other players throughout the world that would certainly like to rip it off.
Other questions? Okay,
One
oh,
final one.
of
Where are
course.
you manufacturing?
Right now,
Yeah, and in the future.
well, in the future, there's going to be a variety of scales, so it depends on where we're manufacturing. It can be anywhere from equipment that can fit right here to fill a building.
We're primarily going to be manufacturing it here in St. Louis.
Yeah, we'll be,
You know, so it's going to be a local, you know, so it's going to be a local business.
Well, it's right.
Okay, and we always like to end with the question, what can the community do for you? How can we help? What do you need?
Well, we're in the process of raising funds right now. Anybody with a background in industry, that would help. I think we're pretty good. We've got it. We can get it done.
Okay. All right. And I'm going to get you reconnected here.